All right, I'm going to show two examples of applications involving bearings. So there's different ways of measuring bearings. It's just another way of explaining angles. So if only one angle is given, then it's assumed that we're starting at north and we're turning in a counterclockwise directions. So let's do an example. Let's say that we have radar stations A and B and they're on an east-west line. So here's west, here's east, and we have A is west of radar station B, and they're 3.7 kilometers apart. So A is further west, there's A, and here's B, and they're 3.7 kilometers apart. Station A detects a plane at C on a bearing of 61 degrees. Okay, so the bearing always starts from north and we're turning around 61 degrees. So it's detecting a plane somewhere on that measurement. This is 61 degrees. Now, meanwhile, B simultaneously detects the same plane on a bearing of, again, from bearings, we're always starting north. We always start north. And we're going 331. Here would be 270. All right, so 331 would be around there. And we're detecting a plane located at point C. Okay, and so although this all the way around was 330, so let's first of all just figure out what our angles are. So angle A, let's see, this is 90, so it would just be 90 minus that bearing of 61 degrees. Okay, and that's 29 degrees, so this is 29 degrees. Meanwhile, angle B, just this section right in here, so angle B would be 360 the whole way around minus that bearing of 331, and so that is 61 degrees. So this is 61 degrees. So if we want to figure out what our angle C is, then remember that all of the angles in a triangle equal 180. So angle C would be 180 minus what we know, which is 29 degrees, and minus the other angle we know, which is 61. So when you work that out, you get that angle C is equal to 90 degrees. All right, good news. So we can use right triangle trig. Excellent. Okay, now let's figure out what else we know. We want to know the distance from A to C. So this is what we want to know. And we know this from A to B is 3.7 kilometers. Now, the side that is across from the 90 degree, that is the hypotenuse. So that's good. And then you could either start with angle A or angle B. It doesn't really matter. I'm going to go ahead and just use angle A. So if I take the cosine of 29 degrees, cosine again is adjacent over hypotenuse. Okay, and the side touching my angle, there's two of them touching my angle, right? One's hypotenuse and one's adjacent. So adjacent, cosine 29, adjacent is my x, that's what I want to find out, and the hypotenuse is 3.7. Okay, I can multiply 3.7 times both sides. So I get 3.7 times cosine of 29 degrees is equal to x. And then you can just work that out on your calculator, and we get that x is approximately 3.24 kilometers. So the plane is approximately 3.24 kilometers away from radar station A. All right, and there's another method, and that is using the north-south line. So we start with a north-south line, and then we use an acute angle to show the direction going either east or west from that line. So we're either turning towards the east. Like for example, you would start looking north and then you turn towards the east. Or you might start looking south and then turn again towards the east. Or you can start looking south and turn towards the west. Or you can start looking north and turn towards the west. So it's a little bit more confusing. We're going always either from north to south, and we're turning either towards the west or towards the east. Okay, so let me do an example of this. All right, let's look at this example. We have the bearing from point A to C is south. So here's A, and we're going from the south and turning in the direction 52 degrees east. So somewhere along that line is my C. All right, now the bearing from A to B is 84 degrees from north. So in the direction of north, I'm going to turn towards the east. And I don't quite get to 90 degrees, it's about 84. So this is 84 degrees. And there is my B. The bearing from, so here's my C somewhere. The bearing from B to C is south and then turning 38 degrees. So this right in here is 38 degrees. All right, so now I'm dealing with a little triangle. Most likely, because it's in this section, it's going to be a 90 degree, but let's figure out what's going on with our triangle. Okay, so there's my triangle, and I've got angles A, B, and C. And I forgot this one. This one is 52 degrees. Okay, there's a couple of things to keep in mind. First thing is, it's just kind of assumed coming into trig that you know this, but most people may have forgotten it. If you have two parallel lines, this is from geometry, and it's crossed by another line, we've got all these interior angles that are equal. So this angle right here is the same as the opposite interior angle. Okay, so let's say this is 84 degrees. The other thing that you need to know is that the angles, this is 180 halfway across. So if this is 84, then this is just 180 minus 84, which would be 96 degrees. So this is 96 degrees. So this would be 96. And then by alternate interior, these angles are both the same. So that's 96 as well. And this one is 84. Okay, so that's the first thing. So that, based on that, I know this angle right in here is 96 degrees. Right, because this here is 96, because 84 and this green angle have to add up to 180. So there's my 94. All right, so that's helpful. Now let's figure out our angles. So angle A, that is, a straight angle. I've got part of it's 84. I've got part of it's 52. So what's angle A? Well, it would just be 180 minus 84 minus 52. So angle A is equal to 44 degrees. Okay, angle B, we have 180. We just figured out that upper angle was 96, and then we were given the bearing of 38. So angle B is 46 degrees. So I'm going to put that in what I have. Angle A is 44, and angle B is 46. Okay, now let's try and figure out angle C. I'm going to kind of erase some of what I got. Okay, so angle C, is all the angles in a triangle are 180, and I subtract the ones that I already know. So minus A, which is 44, minus B, which is 46. And that gives us, drum roll, no big surprise because we're in right triangle trig here, that is 90 degrees. So my drawing isn't quite to scale, but that's a 90-degree angle. So I can kind of make a little bit better picture. This is 90, that's C. This is A, which is 44. And this is B, which is 46. Okay, so now let's figure out what else we're given. A plane flying at 250 miles an hour for 2.4 hours goes from A to B. Okay, so A to B. The distance there, distance is equal to rate times time. So we have a rate of 250 miles per hour times the time, which is 2.4. So our distance there is 600 miles. So this is 600. Now I'm also seeing that that's across from my 90 degree. So this is my hypotenuse. Now what do we need? We need to find the distance from A to C. A to C. That is what I want. Okay, so I can work with either angle A or angle B. It doesn't really matter. Last time I did angle A, so I'll just do angle C or B. Okay, so I'm going to work with this angle right here, and I have an opposite and I have a hypotenuse. So I want to find my opposite, and I was given the hypotenuse. So I'm going to use sine of B, because that would be the opposite over the hypotenuse. And opposite is, let's see, sine of 46. Opposite is x, and hypotenuse is 600. So then we can solve for x by multiplying both sides by 600, and then getting an approximation for x, which is approximately 430 miles. All right, there we go. So the distance from A to C is approximately 430 miles.